Advanced Cryogenic Evolved Stage, ACES. The Advanced Cryogenic Evolved Stage, ACES, was a proposed liquid oxygen, sometimes abbreviated as LOX or Loxygen Liquid Hydrogen, LH2, upper stage for use on a number of different launch vehicles produced by Boeing Company, Lockheed Martin Corporation, United Launch Alliance, ULA. During the last 5 years of the program, ACES was proposed for eventual use on the Vulcan Centaur Heavy Lift Launch Vehicle, HLV, designed by the United States joint venture United Launch Alliance. The ACES concept had the objective to improve the on-orbit lifespan of current upper stages. In 2015, ULA announced conceptual plans to transition the Vulcan Centaur rocket to the ACES second stage, also referred to as Centaur Heavy, after 2024. Vulcan will initially launch with the Centaur 5 upper stage. Both Boeing and Lockheed Martin had separate but similar ACES concepts prior to the formation of the jointly owned, 50% Boeing and 50% Lockheed Martin, ULA in late 2006. In the event, the long-duration upper stage concept was never able to obtain top-line attention from any of the companies as it never won full development funding from the U.S. government, the primary source of funding for the Delta, Atlas Expendable Launch Systems, ELVs, and Vulcan Centaur rocket. However, some aspects of changes planned for ACES, such as the larger tank diameter, were eventually used in the Centaur 5 upper stage. Two Advanced Cryogenic Evolved Stage concepts were originally developed in 2005 by both Boeing and Lockheed Martin. By 2010, ULA had inherited the intellectual property of both proposals, and the ACES concept had evolved into a new high-performance upper stage to be used on both Atlas V and Delta IV heavy launch vehicles. Now called the Advanced Common Evolved Stage, ACES was proposed to be a lower-cost, more capable and more flexible upper stage that would supplement, and perhaps replace, the existing ULA Centaur and Delta Cryogenic Second Stage, DCSS, upper stages. This upper stage was intended to incorporate improved insulation for improved cryogenic storage and longer coast durations. In April 2015, the name of the stage was reverted to the original Advanced Cryogenic Evolved Stage name, as the new ULA Vulcan Centaur design would be the only first-stage rocket intended to use ACES, beginning no earlier than 2023. In September 2020, ULA stated they were no longer actively developing ACES. As of April 2015, ACES was expected by ULA to debut on the Vulcan Centaur launch vehicle no earlier than 2023, but in July 2015 the timeframe was clarified to not likely fly until 2024 to 2025. In 2018, ULA gave multiple presentations that again showed an ACES debut in 2023. In 2019, however, ULA said that while they still planned to develop ACES, they no longer had a specific date for when that would be. ACES was planned to use ULA's proprietary Integrated Vehicle Fluids, IVF, technology to significantly extend its lifetime in space. ACES was planned to include common bulkhead propellant tanks with a diameter of 5.4 meters, 18 feet, capable of carrying 68,000 kilograms, 150,000 pounds, of propellant. In late 2017, ULA decided to bring the 5.4 meters, 18 feet, diameter and advanced insulation elements of the ACES upper stage forward. Under the new plan, Vulcan's upper stage is the Centaur 5, with two LH2 LOX RL-10 engines and no IVF or other ACES extended duration technology as had been planned for ACES. ACES was then expected to have the same tank diameter as Centaur 5, but stretched, longer tank length, with the possible addition of two more RL-10 and IVF. On May 11, 2018, United Launch Alliance announced that the Aerojet Rocketdyne RL-10 engine was selected for Centaur 5, following a competitive procurement process. The IVF technology uses a lightweight internal combustion engine, ICE or IC engine, to use hydrogen and oxygen propellant boil-off, normally wasted when boil-off gases are vented to space, to operate the stage. The design included producing power, maintaining stage attitude and keeping the propellant tanks autogenously pressurized. Using these fluids was designed to eliminate the need for hydrazine fuel, helium for pressurization, and nearly all batteries in the vehicle. IVF was designed by ULA to be optimal for depot operations, since only liquid hydrogen and liquid oxygen would need be transferred, and it could, if built, conceivably extend mission lifetimes from the present dozens of hours to multiple days. As of April 2015, an internal combustion engine to be used to power the IVF system on ACES was to be produced by Roush Fenway Kozlowski Racing, doing business as RFK Racing. In August 2016, ULA's President and Chief Executive Officer, CEO, Salvatore Torri Thomas Bruno said both Vulcan Centaur and ACES were intended to be human-rated. One potential application for ACES was stated by ULA in 2010 to be the use of the longer endurance and the greater fuel capacity as propellant depot with in-space refueling capability to retrieve derelict objects for near-space cleanup and deorbit. These new approaches offer the technical prospect of markedly reducing the costs of beyond low Earth orbit, LEO, object capture and deorbit with the implementation of a one-up one-down launch license regime to Earth orbits.